The Gulf Stream collapse could plunge Europe into a regional ice age, while the rest of the world burns. Recent oceanographic measurements show that the massive Atlantic meridional overturning circulation has slowed by 15% since 1950. This complex conveyor belt of warm water keeps London and Paris far warmer than their icy Canadian counterparts. If this delicate heat exchange fails entirely, the agricultural heartlands of the continent will become frozen and barren. What specific tipping point in the North Atlantic will trigger this irreversible shift toward a permanent European winter? The answer begins with a paradox that most people never consider when they think about climate change at all. Europe sits at the same latitude as Canada's frozen tundra, yet its winters remain mild enough to grow wheat and raise cities of millions. That warmth is not geography, it's a loan, drawn against an ocean current that is now visibly weakening. The debt is coming due, and the collateral is an entire continent's way of life. Picture the Atlantic Ocean as a living engine, constantly moving heat from one end of the planet to the other. Warm surface water near the equator gets pushed northward by wind and the slow rotation of the Earth beneath it. As it travels, it releases that stored heat into the atmosphere above, warming the air that drifts east toward Europe. By the time this water reaches the seas around Greenland and Iceland, it has cooled dramatically and grown heavy with salt. That density is what drives the entire system. The cold, salty water sinks deep into the ocean floor and begins its return journey south. Scientists call this full loop the Atlantic Meridional Overturning Circulation, or AMOC, and it moves roughly 17 million cubic meters of water every single second. Without that constant circulation, the heat Europe depends on simply has no delivery mechanism to reach it. The Gulf Stream is the most visible part of this system, the warm surface current that hugs the eastern coast of North America before crossing the Atlantic. It's not a river, but it behaves like one, carrying more water than every river on Earth combined. That single fact tells you how much is at stake if the engine slows.
The ocean doesn't announce its changes. It buries them in temperature, salinity, and depth.
Scientists began noticing something wrong in the North Atlantic around the mid-20th century, and the signal has only grown louder since. Sea surface temperatures in a region south of Greenland are running colder than the rest of a warming planet, an anomaly that oceanographers call the cold blob. That cold blob is a fingerprint. It marks exactly where AMOC's sinking engine should be pulling warm water down. When the current weakens, heat stays near the surface instead of descending, and the cold blob grows. Measurements taken since 2004 through the Rapid Monitoring Array confirm the current has slowed by roughly 15% compared to its mid-century strength. 15% sounds modest until you understand that AMOC moves more water than every river on Earth combined. The driver behind this slowdown is fresh water, specifically the meltwater pouring off Greenland's ice sheet as global temperatures climb. Fresh water is lighter than salt water, so it floats rather than sinking, and a current that cannot sink cannot flow. The engine is losing pressure, and the question now is whether anyone can stop it. Every system under pressure has a breaking point, and AMOC is no different from any other. Scientists call it a tipping point, the threshold beyond which the current can't pull itself back together. Below that line, The feedback loops that once kept AMOC stable begin working against it instead. Fresh water pouring in from melting ice dilutes the salty, dense water that drives the current's sinking engine. Less sinking means less circulation, which means more warming, which melts more ice and sends more fresh water flooding in. The system doesn't slow down gradually and then stop. It accelerates toward collapse the closer it gets to the edge. What makes this terrifying isn't the collapse itself. It's that we may not recognize the threshold until we've already crossed it. Scientists estimate the critical point could lie somewhere between 1 and 4 degrees of additional ocean warming. That range sounds manageable, until you realize current trajectories put us inside it before the century ends. The question isn't whether a threshold exists, it's whether we're already close enough to feel it pulling.
The same ocean current that keeps London warmer than Newfoundland could, within decades, simply stop delivering that warmth. Scientific models project that a full AMOC collapse would drop average temperatures across northern Europe by 5 to 15 degrees Celsius. That isn't a gradual chill you'd barely notice across a generation of slightly colder winters. Paris would experience winters comparable to those currently endured by cities deep inside Canada. London's climate would shift towards something resembling present-day Reykjavik, where frost arrives early and stays long. Scandinavia, already cold, would cross into conditions that make large-scale agriculture functionally impossible across entire regions. The cruel irony is that this regional freeze would unfold while the rest of the planet continues to warm. Southern Asia, Sub-Saharan Africa, and the Americas would absorb the heat that Europe's ocean conveyor no longer redistributes northward. Europe would become a cold island inside a warming world, isolated by the very physics that once protected it. That isolation wouldn't stay contained to temperature readings and seasonal forecasts for long. The first fields to fail wouldn't announce themselves. They'd simply stop producing what they once did. Growing seasons across northern Europe could shrink by 6 to 8 weeks, almost overnight in climate terms. Wheat fields in France and Germany, which feed hundreds of millions, would face temperatures they were never bred to survive. The soil itself would harden earlier each autumn, locking nutrients away before crops could absorb them fully. Farmers wouldn't just lose one harvest, they'd lose the reliable cycle that every planting decision depends on completely. Supply chains built around European grain exports would fracture, and the shortfall wouldn't stay inside European borders for long. Import markets would tighten globally, pushing food prices into ranges that poorer nations simply cannot absorb or manage. What begins as a regional temperature drop becomes a global food security crisis within a single decade. Governments that depend on stable harvests for political stability would face pressure they've never encountered at this scale. And as fields go cold and empty, people follow the food. Migration wouldn't be a policy debate anymore. Europe freezing wouldn't mean the rest of the world catches a break. It would mean the opposite. The heat that AMOC once pulled northward has to go somewhere, and it doesn't simply vanish into the ocean floor. Without that northward pump, tropical waters in the Atlantic would grow warmer, feeding stronger and more destructive hurricane seasons year after year. The monsoon systems that billions of people in South Asia and West Africa depend on would shift, arriving late or failing entirely in critical growing regions.
Brazil's rainfall patterns, already under pressure, would fracture further as the Atlantic's circulation rewrites the rules of moisture delivery across the hemisphere. A cooling Europe and a heating tropics wouldn't be two separate crises running in parallel. They'd be one system, tearing itself apart at both ends. The chaos wouldn't be evenly distributed, and that's precisely what makes AMOC collapse so dangerous to model and so hard to prepare for. What science can tell us, and what it still cannot, is where the real uncertainty lives.
Scientists can tell you the Gulf Stream is weakening, but they cannot tell you exactly when it breaks. That gap between what we know and what we don't is not a failure of science, it's the most dangerous territory on the map. The models that predict AMOC collapse range from decades away to centuries away, and that spread is not a small margin of error. It means the difference between your grandchildren adapting slowly and your children facing a crisis with no warning at all. What makes this harder is that the system may cross its tipping point silently, with no obvious signal until the collapse is already underway. We've never watched an ocean circulation system fail in real time, so every projection carries genuine uncertainty baked into its core. What scientists do agree on is that the risk is real, the direction is wrong, and the window for action is narrowing with every passing year. Waiting for certainty before responding is itself a choice, and history is not kind to civilizations that made that choice. The science won't give you a date. What it gives you is a warning, and warnings only matter if someone is listening.